And let's tackle this next one here. So first things first, let's understand the question sentence, everybody. That's the first thing we always want. So here, if you buy 5 pounds, how much will it cost? Okay, so let's think about that. What we see here is that it says a hardware store sells parcels for 21 cents per ounce. And if you buy 5 pounds, how much will it cost? Everybody, before we even get to thinking about this problem, do you very clearly see that we have a discrepancy, that we have an inconsistency with the units here? Because we see that we're selling here the price per ounce, but then over yonder, we see 5 pounds. Do you see that logic that's a little broken there that's going to require us to take a moment to pause? So, boom. Even if you don't know what to do, I hope you can recognize that we have a weight in ounces and then weight in pounds, and that can be inconsistent. That inconsistency has to get figured out. So here's how we're going to figure it out. If we're going to get that total cost, what we're going to have to do is we're basically going to have to take the cost, whatever that is, and multiply it by the weight, whatever that is. Let's take a look at those two things. We have 21 cents per ounce, and then we are trying to buy 5 pounds of this. Everybody, here's the easiest way we could do this. If this says 21 cents per ounce, does that mean that if we multiply by the number of ounces, we would get the total weight? Does that ring true for anybody here? If we have 21 cents per ounce, if we multiply by the number of ounces, yeah, we'll get that total cost. In the same sense of like, hey, if we had 3 ounces, 21 cents times 3, yeah, that's 63 cents. That's 3 ounces. That's how that would work. And so in this case, we can't just multiply by 5 because it's 5 pounds. Let's convert this. So I'll bring this over here. Everybody, if we're converting pounds to ounces, what's that conversion rate? It's 1 pound equals 16 ounces. And so ask yourself, are we going from big to small or small to big? Well, we're going from a bigger unit to a smaller one. And so that means multiplication. And so with that, we'll multiply by 16. So with that, we have 16 times 5. 6 times 5 is 30. Carry the 3. Then we have 1 times 5 is 5. Carry the 3 is 8. So that means we have 80 ounces. So again, we have 21 cents per ounce. We're going to multiply it by the total number of ounces to get the total price. And so that's going to be times 80. So here we go. We'll have the 21 cents multiplied by 80 right over here. And that's it. 1 times 0, 2 times 0. Now we'll move on to the next line. 1 times 8. 2 times 8 is 16. Add all of this up. And we end up getting 0, 0 plus 8. We get 8, 6, and then 1. From here, everybody, how many decimal places are we bringing back? Yeah, we're bringing back 2 places. 1, 2, 1, 2. So this turns out to be $16.80. Everybody, which answer choice is the closest one to it? Answer choice C. That is the closest to $16.80 at $16 flat. And there we go. Notice how this one was more about understanding the in-between, where that unit conversion actually came into play versus just taking everything, multiplying it together, and hoping for the best. So remember, everybody, we don't want to recognize patterns as much as we want to be able to identify and apply the knowledge that we know. In terms of, again, small to big and big to small to guide the conversion on top of knowing the actual conversion rate. All right, so let's tackle this question here. I think this one is a very good problem to leave off on because it takes, again, some thinking because in terms of the session that we're doing right now, we haven't done this yet. So let's give it our best shot. So first things first, no matter what, our goal is to read the question first. So here we go. Let me grab my highlighter and let's interpret the question correctly. If the overall average speed for the entire journey is 250 miles, again, extra information. This is information that we can use, not use, I don't know yet. I want to read the actual question. It says, what is the distance flown during the second leg in miles? Okay, sounds good. That's what I want to highlight, everybody. What is the distance flown during the second leg? Everybody, does it make sense that we are going to have the first leg, second leg, and then a total? But all we want is the distance for leg number 2. Does that make sense before I start taking down all of the information? Cool. Sounds good. Again, remember, that's the best thing you can do for yourself. You don't want to try to walk straight into a hurricane or a natural disaster. You want to brief yourself first. So boom, we want the distance for the second leg specifically. I've got that in my head. And now let's go into the information. So first sentence, an airplane flies, right over here. An airplane flies from city X to city Y at 300 miles per hour, covering 900 miles. On the second leg, it flies for 2 hours. So let's write these pieces of information down. So over here for leg number 1, from city X to city Y, this is the first leg. Our rate is 300 miles per hour. And then our distance covered right over here is 900 miles. D equals 900. All right. So before we even continue, my party people, do you see that for this first leg, we have what we need to find the time if we needed the time? Do we see that we have enough information to find the time if we needed to? Okay, sounds good. So just keep that in mind. Just in case we need to circle back and actually do that, we'll keep that in mind. Let's keep reading here. On the second leg, it flies for 2 hours. That's all the information we have for the second leg. For the second leg, 2 hours is the trip. That's all we're given in that sentence. So let me write that down. T equals 2 hours. That's not the first leg. That's the second leg. Then we're given in the next sentence that the overall average speed for the entire journey is 250 miles. Okay, sounds good. So here we go. The total rate or the overall rate for the trip is 250 miles per hour. All right, everybody. We have now written everything down. What we are looking for is the distance for the second leg. We have the time for the second leg, but we don't have the rate. So here's what we can do. We can do our best to try to, use all this information to try to find that rate, because then we can get the